Hello, this is Zhao Suojiang, a faculty member in School of Engineering at San Francisco State University. And this is part of a series of videos to help you prepare for the ENGR 309 Mechanics of Solid course at San Francisco State University. And today we're going to talk about reactions. Here on the board, we have a simply supported beam with a portion of it sticking out on the right-hand side. And this beam now currently have two supports. On the left side with the triangle that's called a hinge. The support on the right hand side is like a roller, and that actually called a rollers. And a hinge is a support that resists the movement of the beam both horizontally and vertically. Therefore, the reaction for this support is going to have two components. And the rollers on the right hand side on the B point is only resisting the movement of horizontally. Therefore, the reaction's only going to be once horizontally. Before we can calculate the reactions, one thing we need to do first is to do something called the free body diagrams. In the free body diagram, what we need to do is we take out those supports and then expose the reaction force. For example, on the support 8, we're going to have a y in the y directions. We're going to have ax. And on the roller point, we're going to have only one component, which is going upwards. And we're going to have the external force. And this is our free body diagram. To find out the reaction force, what we can do is we first sum the moment at point 8. And I'm going to use clockwise as positive directions. Since this beam is in equilibrium, therefore if you sum the moment at point 8, you're going to have your sum equal to 0. And with that, if you draw those out, you're going to have your ax, because ax is passing through the point A, therefore the moment arm is going to be 0. Same for ay. For the point B, if you're taking the moment at point 8, the moment arm is going to be 5 feet. And since it's going to create a counterclockwise moment, therefore it's going to be negative by times 5 feet. And another force we're going to have is this 10 kips external force. And if you take the moment at point 8, this force is going to be clockwise. Therefore, it's going to be, change that to 10 times the moment arm is going to be 10 feet. All right, if you calculate that out, so that is your 5 by, and it's equal to negative 100. And your by is equal to negative 20 kips. What does this negative mean? All right, first we assumed this by is going upward, and then we use that directions to calculate these equations. If we calculate if the results come out to be negative, that means the direction you assume is actually not true. Therefore, your by can be written as 20 kips, but the direction is going to be going downward. Right? We can do the same thing to take the moment at point B, use clockwise as positive directions. And if we do that, we're going to have ax, because ax is passing through the point we're taking the moment. Therefore, the moment arm is going to be 0. And for the ay, if we're taking the moment at point B, it's going to create a clockwise moment. Therefore, it's going to be positive. The moment arm for ay is going to be 5 feet. And another force, another moment we need to add to that is your 10 kips. And if you take a moment at this point, and this force is going to create a positive moment, a clockwise moment as well. So that is 5 equal to 0. With that said, you have your 5ay is equal to negative 50 kips. And your ay is equal to negative 10 kips. And it seems like we make a mistake here, because when you move this term to the right hand side, you're going to have this negative 5by is equal to negative 100. Therefore, your by is actually positive. All right. And with that said, your by is actually going upward. So that is something that we need to keep in mind. The directions is very important when you're calculating the reactions there. Okay, let me erase that. And after we calculate the reaction for ay, by, ax, we need to check to see if that is correct, right? We can check if the force going upward is equal to the force going downward. And what force we're going to have on going upward? We have this 20 kips here. We have the 20 kips. That is our by. And on the right hand side, the force going downward, we have this ay, which is 10 kips. And also we have this external force, 10 kips external force. The left hand side is equal to the right hand side, therefore our calculation correct, so it's okay. So with that said, the final free body diagram is going to be your ay going downward as 10 kips, and your by is going upward as 20 kips, and you have your external force at the end as 10 kips. To conclude, we have 3 steps here. The first step is to sum the moment at the different point. For this case is point A and point B, and to find out the reaction force. The second step is to check to make sure we didn't make any mistake like I did here. Check the force going upward is equal to your force going downward. If the force not match up, force not matching up, then look for mistake. All right, and that is all for these reactions, and thank you very much for your attention.